So next is magnetic flux density. What is magnetic flux density? It is number of field lines passing through or crossing a small area which is kept perpendicular to the magnetic field lines. That is what is magnetic flux density. Number of, simply you can say number of field lines per unit area. So which is nothing but magnetic field. So magnetic field technically you can explain in this way also. Flux per unit area. Okay. So what will be the unit? So B is equal to flux per area. Okay. What is the unit of this? Unit is nothing but Weber per meter square. Weber meter raised to minus 2. Okay. And I can also call it as Tesla. Okay. Alright. So this is what is magnetic flux density. Next is uniform magnetic field and non-uniform magnetic field. You know what is uniform and non-uniform. Examples are given. This is what is uniform. Look at this. Look at these three. Non-uniform magnetic field. Okay. So even if you look at this seems like this has a regularity or a symmetry it has. For example, look at this. Yeah, it seems symmetrical, but it is not a uniform magnetic field because at this place and this place magnetic fields are different. But look at this here, this region, everywhere magnetic field is same. Okay. And next one, this is what is uniform and non-uniform magnetic fields. One of the example is Earth's magnetic field. Earth's magnetic field at a local area, that will be uniform. Alright. So next is example 3.4. You can check the question. So there is a magnetic field, magnetic dipole is given. So there is south pole and north pole. That is nothing but it's a bar magnet. So question is, what will be integral B dot dA? Okay, what will be the flux, net flux, which will be equal to 0? Why? Because when you consider this surface area, entire surface area, so the net magnet or the magnetic pole strength is equal to 0. Why? These are equal and opposite. There is no single pole, there is no additional single pole inside this closed surface area, so there will not be any magnetic flux or the net magnetic flux inside this area, or this will be 0. Okay, so this is a magnetic dipole, this is a bar magnet. So integral B dot dA is equal to 0. This is this seems like Gauss's law in electrostatics. Yeah, it seems similar to Gauss's law in electrostatics. Alright, because net charge inside the Gaussian surface is equal to 0, then flux will be equal to 0. So I think this is all about the properties of magnets, and we will continue the discussion. Alright, thank you.